Whenever I see a big block of text like this, I'm just going to skip right to the end. And those who watched the previous videos may notice that I figured out how to get rid of that menu that pops up. All right. It's an area question, of course. Which of the following is close to the area of the shaded regions? All right, fine. So just looking at the geometry of this, we're going to want to find maybe the area of the square, area of this circle. We want to find the area of the sector and subtract it. We're going to find the area of this triangle. And then we're going to find the area of this sector and subtract those two things. So that's my plan. Let's see if they've given us enough to do it, or maybe even make it simpler than that. But let's go. It tells us that the circle is an 8-inch radius. That means that the square has a 16-inch side. So the area of the square, of course, is 16 squared. Pull up my handy-dandy calculator here. I don't have 16 squared memorized. If you do, kudos to you. So that's 256 is the area of the square. So area of square. That means half the area of the square is what? 128, and half of, so that's going to be just this rectangle. Can't see my mouse. There it is. That rectangle there has an area of 128, and if we take half again, that's an area of 64, and half again, area of 32. Neat little trick there, right? All right. Yeah. You could also remember that this is a length of 8, and of course 64 for the square there anyway, and half 32. So the area of our small triangle is 32. Remember, we're going to take that and we're going to subtract the area of this sector to find this white space here. Why do I want the white space? Because it's going to be easier to find the hole and subtract the white space to find the area of it. I've already got the hole, 256. So I know that D is wrong. We're only subtracting a little bit, I think. So it might be C. Could be B. It's definitely not A. Because just this quadrant down here is already 64. We could do some adding here. 64 and 64 is 128. These guys are going to be just a little less than 64. A little less than 128. Oh. Either way, we got to find the area of that sector no matter how we do it, and because that's going to be used for both of these calculations. Area of a sector. So area sector is equal to the fraction of the circle that you have, so number of degrees out of 360, times the area of the circle, pi r squared. So they didn't give us the angle measures on this thing, but this is a diagonal. So we can pretty safely assume if this is a square, indeed it is, this is a 45-degree angle up here. That means this must be 45-degree angles here, assuming AB is a midline. Yeah, parallel to the two sides. So that's 45 degrees right there. 45 degrees out of 360 times pi, radius, remember, is 8 squared. 45 out of 360 does reduce nicely. What is that? That's 1/8, if I'm not mistaken. Pi times 64. 64 over 8, of course, is 8. Pi is the area of that sector. None of our answer choices have pi in them, so they want us to calculate it out. And I'm just going to double check my math here. Yep, that is 1/8. And 8 pi is roughly 25. The area of that triangle, you'll remember, is 32. So the total triangle, or the total area of this thing is going to be 256 minus roughly 25 for this sector here, and then minus again the area of the triangle, which remember was 32, minus the area of the sector, which is 25, so we're going to minus 7. So 256 minus 25 minus 7, that's 32. That's going to be 224. And they did say is closest to, which does allow us to round. Whenever you see that kind of language, or approximately, or closest to, or nearest value, they're basically giving you permission to round. So that's going to be C. Wow, what a doozy on number 21.